Well, welcome. In this video, we're going to be looking at Lesson 1.3. Lesson 1.3 is all about creating and using histograms. So we're going to learn how to create a histogram, and not only that, but how to use that histogram to be able to make conclusions based on the graph. But before we get into how to make a histogram, let's first talk about some terms here that we need to be familiar with. The first term is distribution. Distribution is a function whose values are the frequencies, the relative frequencies, or probabilities of mutually exclusive events. And basically, all a mutually exclusive event is a situation where it's non-overlapping, where we don't have information that's going to overflow from one piece to another. And we'll look more at how that is going to work out here in a little bit. But we have a histogram. A histogram is basically a bar graph, but it's even more than a bar graph, because in a histogram there's not going to be gaps between the bars along the x-axis, as opposed to having a category where we're going to be graphing. It's going to be broken up into a scale with equal widths. So that's what a histogram is. So it's not the same as a bar graph, but it's going to look very similar to a bar graph. And we have two different types of histograms. One's a frequency histogram. That's going to display the number of values that are within each interval. We could also have what's called a relative frequency histogram. And in that case, we're going to be displaying the percent of values in each interval. So it's important that you understand the difference, because if in your assignment, if they ask you to graph a frequency histogram, we're going to be graphing the number of values in each of the intervals, where the relative frequency histogram is going to be dealing with the percent of values in each interval. And we'll look at how to create these in this lesson. So why don't we go ahead and look at our first example that's going to be shown here. Now, in this example, it says the number of representatives that each state has in the U.S. Congress depends on the population of the state. Below are the numbers of representatives from each of the 50 states in the 110th Congress from 2007 to 2009. Now, looking at all those numbers, it really doesn't tell me much. It's hard to really draw out any conclusions based on all these numbers. So that is the purpose of creating a histogram. Now, they've already created the histograms for us. So let's scroll down here. And you can see that this first histogram is a regular frequency histogram, where the graph here on the y-axis is represented as the number of values in each of these bins, or what we call them, the bars here for the histogram. So here between 0 and 5, there's a total of 20 representatives, or 20 states that have 0 to 5 representatives. The number of states that have 5 to 10 representatives is a little over 16, so maybe 17 states, and so on. So that's how we would read our graph. Now, that's a frequency histogram. A relative frequency takes that data and puts it in terms of percents. And you can see the graph is the same graph, it's just that our y-axis here is in terms of percents. Well, let's answer some questions based on this data now. It says, about how many states have 15 to 19 representatives? So that would be looking at this bar here. So that bar looks like there's about 4 states that have 15 to 19 representatives. So that would be our answer. Then it says, what percent of states have 20 or more representatives? So it's asking for a percent, so we're going to use our relative frequency for that. And we're looking for what percent of states have 20 or more representatives. So for that, we're going to be looking at these 3 bars. And we're just going to have to do some estimating here. So let's say this here, let's estimate that. That's about halfway between 0 and 8. So I'm going to estimate that to be 0.04. This one here looks to be half of that amount, so I'm going to use 0.02. And I'm going to assume this is about the same of 0.02. So if I add those together, I would get 0.08. And we're looking for the percent, though. 0.08 is the same as 8%. So we would say 8% of states have 20 or more representatives. It says, in what bin does the median number of representatives fall among the 50 states? Well, this requires us to do a little bit of thinking, because if you recall from the previous lesson where we learned about a median is the middle number when the numbers are arranged from smallest to largest. So it'd be a real pain to have to arrange all 50 of those numbers to find out what bin the median number would fit in. So let's think about this for a second. And by the way, just to make sure we're clear on this, the bin is referring to the bars for the histogram. So let's think about that for a second. So if there's 50 numbers, that's an even number of pieces in our set. So there's actually going to be two middle numbers. It'd fall between the 25th and the 26th number, because half of 50 is 25. So it's going to be somewhere between the 25th and 26th number in our data set. And that's enough for me to figure out which bin it's going to be in. So you can see that the first 20 are in the first bin. So that means the 25th and 26th number in our sequence is going to be in the second bin, which is going to be in that 5 to 10 range. Now there's a certain way, though, that we need to write this. So here's the way we're going to do it. We're going to say that it's going to be between 5 and 10. And since we're dealing with representatives, maybe we'll use R for the representatives. Now, the way they have these bins set up is that from 0 to 5, 0 would be included in that bin, but 5 would not. In the next bin, for 5 to 10, 5 would be included in that next bin, but 10 would not, because 10 is going to be included in the next one, if that makes sense. So 5 is going to be included in this one, but 10 is not. So the representatives in this particular bin, or this bar for the histogram, 5 would be included, but 10 would not. So we would have 5 is less than or equal to the number of representatives, which is less than or equal to 10. Now part E, it says, what percent of states have fewer than 15 representatives? So what percent of states have fewer than 15 representatives? So if we're dealing with the percent, we need the relative frequency. So we're going to go back over here to the histogram on the right. And what percent of states have fewer than 15? So that would be referring to these three. Well, we're just going to have to estimate on some of these. So let's look at, this one's pretty clear. That's going to be 0.4. This next one is a little bit over 0.32, so I'm just going to estimate that to be about 0.34. And same thing with this one. This is a little bit over 0.08, so I'm going to estimate that to be 0.10. And if I add those together, I get 0.84, which is 84%. So I'd say 84% of the states have fewer than 15 representatives. So that's how we can use a histogram. Now let's figure out, well, how do we draw a histogram? Now really there's going to be 3 steps that we're going to have to follow to create a histogram properly. The first step is to organize the data into what we call non-overlapping equal intervals. And that's what our bins are going to be made up of. And then we're going to count or tally the number of observations in each bin. And then we're going to put everything into the histogram. We got to remember that there's not going to be any gaps between the bars. And to illustrate that, or to make sure that I understand, or you understand what I'm talking about as far as no gaps between the bars, you might say, well, wait a minute. In the last one, there are some gaps here. Well, that's because there was no information in those bins. So it's okay if there's empty bins. But if you notice my bars or my bins here, where we do have information, there's not any gaps. Okay, so let's determine a good scale here. So if I look at my information, I want to the way that I want to start this out is I want to look to see, well, what's my largest piece of information and what's my smallest piece of information, and that'll help me create a good bin size. So as I look across here we have a 71. Is there anything larger than 71? I don't see anything else larger than 71. And now I got to figure out, well, what's my smallest number in this data? And I see that we have 27 here. but I don't see anything smaller than 27. So basically my range of information goes from 27 to 71. So what I'm going to do is I'm going to create bins of size 5. And what I'm going to do is I'm going to have my first bin start with 25. I'm going to do this over here. And so now if I have a size 5 for my bin, what that means is it's not going to go from 25 to 30 because we're including 25. So if you count on your fingers, 25, 26, 27, 28, 29 will be my first 5 numbers. So it's going to go from 25 to 29 would be in that first bin. And then from 30, and for some reason the edge of my tablet's not working, so let me move over a little bit. So we have 25 to 29 is our first bin. From 30 to 34 then would be our second bin. And then 35 to 39 would be our other bin, and I'm going to keep going here. Okay, so I have all my bins created where I can include all of the numbers now that are in this data set. So that's my first step. My next step is to start to count the observations that are in each bin. So I'm going to basically tally these up. So let's start with the 69. So that 69 would go down in this category. So I put a tally mark there. 60 would go in this bin. 34 would go in this bin. 41 would go in this one, and so on. Well, there, so your frequency should look something like this. So now what we're going to do is we're going to use all this data that we just gathered to create our histogram. Now, just like the other bar graphs that we've talked about in the past, you want to make sure that you start by labeling your graph with a title. And this information that we're graphing here is dealing with the daily temperatures, daily high temperatures in March for Lincoln, Nebraska. So we want to make sure that we label this properly, so I'll do that. So there's a good title. And now we want to create our X and Y axis. And along our X axis is where we're going to put all of our bins, which is what we have over here. So we're starting with 25. We're not starting with 0, so let's actually put 25 here a little bit over. But now each of my bins I want to have equal widths. So I'm going to do that along the bottom here. And so we'd have 25. Now I don't put 29 here, I put 30. So we basically put the first number from each bin here. So from 25 to 29 is this first bin, but the next one starts with 30. So 30 to 34, so then we'd have 35. And if you notice, we do have to go up to 75 to make sure that we can squeeze in that last bin. Now we need to do our frequency. We're just going to do a regular frequency table. So the frequency is going to be the number of times that, the number of items that we have in each bin. So the largest bin is for the 40 to 44 range, and that's got 7. So we want to make sure that our y-axis here goes up to at least 7. And we want to label these. So along the bottom, this is referring to the temperature. And it's in, and then the y-axis would be our frequency. Okay, so now we're just going to create our bars. So from 25 to 30 in that bin, we go up to 1. The next bin also goes up to 1. Same thing with the next one. And then the next one is the one that goes up to 7. And from 45 to 49, that's 5. From 50 to 55, there's 3 of them there. From 55 to 60, there's also 3. From 60 to 65, that goes up to 6. From 65 to 70, that's back down to being 3. And 70 to 74 being 1. So there's our histogram. So that would be a properly made histogram. So your information, when you graph a histogram, it should look very similar to this. You want to have equally spaced bins. You don't want to have spaces between the bars. The only time that you have a space or a gap between the bars is if there's 0 items in that particular bin. You want to make sure that you label everything, give your graph a title, and make sure that you label the X and Y axis. Let's talk about if data is skewed. Skewed. Histograms A and B down below here are a skewed distribution. Histogram B tapers off towards the right end to form a tail. So if you notice, if we look at graph B, it's tapering to the right, so it's going down towards the right. And a histogram is close to being, or histogram C is close to being symmetric, with 2 sides at approximately the same shape. To describe the shape of a distribution, consider the following questions. Is the data skewed? The way that we would phrase this graph B, where it's skewed to the right, where it's trailing off to the right, we would say this is skewed to the right. It's important to understand that when you say that something's skewed, you're not looking to see where all the data is. You don't say, oh, all the data is over here to the left, so it's skewed left. You look to see the direction that it's tapering off. It's tapering off to the right, so we would say it's skewed right. Graph A really isn't skewed because it kind of goes up, and then it comes down, and then it comes up again, so it's not really skewed to the left. If this first one had been taller, and this last one had been shorter, then you could maybe say that it's skewed to the left, but that's not the case. And graph C, it's pretty evenly distributed. It's symmetric on both sides there, so that's not skewed either. So make sure you understand what it means to have data that's skewed. Let's end by looking at these last 2 histograms. So let's look at what's going on here. This is what we call population pyramids. Sometimes demographers use histograms to analyze populations. One display is a double histogram called the population pyramid, and 2 examples are shown below. So here we have a population in 1980 where we're comparing the male population and the female population in different age groups. So notice the population in this case is on the bottom as opposed to the side, and in the middle you have the different age group. It's kind of like a stem and leaf plot if you're familiar with those that you might have seen in the past. And then they did the same thing with the data for the predicted data for the year 2020, comparing again the male and female. So let's answer some of these questions. Let's look at this first one. It says, for 1980, estimate which age group had the greatest population. So again, we're going to look up here in 1980. The greatest population is clearly the 20 to 24 age group for both male and female. So that's going to be our answer for part A. For 2020, compare the distribution for men with the one for women. In what age groups are they most different? So you can see that they're mostly the same for a lot of the age groups, but it looks to me that the ones that they seem to be the most different is the 85 plus and 80 to 84. So we're going to say 80 to 85 plus is where they're the most different. Some other observations that we could make and that we could compare is, again, is that for the most part they're pretty equal from the ages of 0 to 75, or 79 I should say. And then it says in part C, compare the 1980 and 2020 population pyramids and describe 3 significant differences. So you can see that one major difference is that the population kind of peaked in 1980 between the ages of, let's say, 15 and 25. where in 2020 the prediction is that there's really no peaking. It pretty much stays steady from the ages of 0 to 60. It's not until after the age of 60 or 65 that the ages start to decline, or the population in those age groups start to decline. But there's a number of different observations we can make. There's just a couple. Let's look at part D. In 1980, which age group had the least population? And give an estimate for this population. So in 1980, the one that had the least, looks like it's the 85 plus. So we want to come up with an estimate. Now remember, this is made up of both male and female, so we're going to have to add two numbers together. So in the males, it looks like there's about 1 million males in that category, and about maybe 1.5 million females. So we're going to say about 2.5 million people in that category. And lastly, it says in 2020, which age group is projected to have the least population? And we're going to give an estimate there. So if we look at this data for 2020, the least population in this case is going to be, it looks probably more like the 80 to 84. Looks like it's going to be slightly smaller, even though for the men it's a little bit larger, but you can see the gap here for the female, it's smaller for the females. So we're going to go with that. We're going to go to the 80-84 range. But again, we're going to have to make some estimations here. So it looks like this one is about, I don't know, let's just say 2.5 million there. And for the females, say it's about, I don't know, 3.5 million. So if we add those together, we get about 6 million people. So this would be the 80 to 84 range, and we're going to say it's approximately 6 million people. So there you have it. So there's a lot to reading histograms. It's really, usually it's pretty easy. The most challenging part is creating the histograms. So you just want to make sure that you remember to start with looking to see what the smallest number is in our data set and the largest number. That'll help you come up with a scale. And then from there, it's pretty easy as well. So with that, good luck now as you attempt your assignment.